We learned in section 1 the first set of identities, right? The Pythagorean identities, which were the biggest ones. And also, some of the smaller ones like the cofunctions, the reciprocal identities, and so on. Well, here in section 4, we're going to learn a new set of identities. These are called the sum and difference identities. Okay? And it's because we use these when we have sine, cosine, or tangent of two things that are being added or two things that are being subtracted. So for example, look at this. It's cosine of two things being added to each other. So the sum of two things. Or it's cosine of the difference of two things, right? Two different angles. That notation there, those symbols are the Greek symbols alpha and beta, right? That's where the word alphabet comes from, right? Alpha and beta and aleph and bait. Yep, okay. So that's alpha, and beta is like a curly B, capital L. That's okay. All right. So now, okay, it kind of is okay. So there is a pattern if you write it with the signs first. So sine of alpha plus beta looks like this. So it's sine of the first angle, cosine of the second angle, plus cosine of the first, cosine of the second. So notice the pattern. It's sine, cosine, cosine, sine. Sorry. Ooh. Sine, cosine, cosine, sine. And look at the angles. It's alpha and beta here in the beginning. And then in the first term, it's alpha and then beta and then alpha and then beta. So you see how the angles stayed the same, like the order of the angles stayed the same, alpha and beta, and then it's sine, cosine, cosine, sine. And then if there was a negative here, so if it was sine something minus something, then that would just be a negative there. Okay? And then if it was cosine alpha plus beta, then it would be cosine of the first, cosine of the second, minus, this time the plus switches, sine of the first, sine of the second. And if there is a minus here, then there is a plus here. Okay, and if you write it in this order, sine first, then the cosine, it goes with a tune, right? Do you guys know the Pop Goes the Weasel song? How does it go? So it's similar to that. So here's how it goes. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Right? It's almost like that. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay? And that's how we learn it. Sine, cosine, cosine, sine. It will help. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Yep. Tangent is a whole situation of its own. You just have to look at the pattern, right? If it's tangent alpha plus beta, it maintains the plus, so it's tangent of the first plus tangent of the second, and then it changes the sign here, and then it switches over there. You just have to memorize them. That's all. All right? So memorize these. You will not be given them. Okay? Okay. Why do you even care about these? Well, because, okay, so great. We know how to find sine of 30. Okay? We know how to find sine of 45, cosine of 60, cosine of 90. But how about like sine of 15? That's not a special angle. Cosine of 75, that's not a special angle. This gives us a way to also be able to find some of those non-special angles. Okay? So, for example, sine of 75. Well, 75 is not a special angle, so I don't know. I don't know how to do that one. That's not on, one of the special angles on the unit circle. But guess what? 75 can be written as a sum of two special angles, right? Which two special angles add up to 75? 45 and 30. Or 30 and 45. It really doesn't matter the order in which you write it, okay? But whatever order you choose, you have to commit for the rest of the problem. So if it's 30, then 45, it's got to be 30, then 45. And so now look, this is sine of alpha plus beta. So we're going to do sine, cosine, cosine, sine. Okay, let's do it. So sine 30 cosine 75 plus cosine 30 sine 45, not 75. Sine, cosine, cosine, sine. And do you see how it's 30, 45, 30, 45, 30, 45? Fabulous. But now, look what happened. I can totally find the values of each of these. Because do we know what sine of 30 is? Yeah. It's a half. What's cosine 45? 1 over root 2. What's cosine 30? Root 3 over 2. What's sine 45? 1 over root 2. So this is 1 over 2 root 2 plus root 3 over 2 root 2. Oh my, they even have the same denominator, so I can combine them into the same denominator, and it'll just be 1 plus root 3 on top. I mean, how fabulous is that? Okay? Now, if you're the type of person who likes to rationalize their denominators and use a root 2 over 2, you still get the correct answer. Okay? So don't worry about it. But it will look different. So it'll be like root 2 plus root 6 over 4. But it's fine. I know them to be the same. Okay? All right. Okay. This next one has a few things going on. Number one, there is a negative inside, right? But what did we say about sine of negative theta? It goes to the front, so it's negative sine of theta. So first off, this will be negative sine of 7 pi over 12. Now, I need to split this into two fractions that add up to 7 pi over 12, but they have to be one of the radian, like, the pi over 3, pi over 4, 2 pi over 3, one of those. So I have come up with a foolproof way of doing it. All right, you want me to tell you?
Yes, please.
Okay, so 12 and 12, yeah? Now, and then it's like something pi plus something pi. Okay, you now want to come up with two numerators here that add up to 7, but they have to reduce to a special angle on the unit circle. So for example, so you can do 1 and 6, right? That adds up to 7. But does 1 over 12 reduce? No, so that's not going to work. So what's another one? 2 and 5 doesn't work either, but 3 and 4 works, right? 3 and 4, because now when you reduce, this will be negative sine pi over 4 plus pi over 3. Okay, and that's totally 7 pi over 12. Oh my God. Like, how satisfying is that? Okay, so negative. Okay, negative stays outside. So now it's sine, sine again. So sine, cosine, cosine, sine, right? So sine, cosine, plus cosine, sine. It's like a puzzle. Negative. Okay. What's sine of pi over 4? 1 over root 2. Cosine of pi over 3? 1 half. Plus cosine of pi over 4 is 1 over root 2. Okay, sine of pi over 3. If cosine was the 1 half, then the sine has to be root 3 over 2. See how that works? So now, look, the denominators are the same again. So it's going to be 2 root 2 in the denominator. And on top, 1 plus root 3. Okay? All right. Now, there are a few ways of writing this. You can either do it like this, negative 1 plus root 3 over 2 root 2. Or distribute the negative into the numerator, negative 1 minus root 3 over 2 root 2. Both are equivalent and equally acceptable. Okay? How does that feel? Yeah.
I guess that
it comes with practice, that P word. Okay, here we want the exact value of this. Okay, so now you look at that and you're like, oh my God, what the heck is that? Like, where did that come from? What is this with the 78 and the 18 degrees? Like, not cool. And then you look a little bit deeper or closer and you're like, wait a minute, that's a pattern. Tangent of an angle minus tangent of a different angle, 1 plus tangent of the first, tangent of the second. Why are you saying, oh, what happened?
That's a difference.
That's, yep. Look, is that the same pattern as this? Yep. Is that the same pattern as this? Tangent of something? Oh, that's a minus, so it's not that one. It's this one.
Yeah.
Tangent of something minus tangent of something else equals 1 plus tangent and tangent. So what does that equal to on this end, right? Because if we could go from left to right, we could also go from right to left. That's tangent of the first minus the second. So this is just tangent of the first minus the second. And that subtracts to what? Oh my gosh, that's totally like a special angle. Right? And tangent of 60 is root 3. So let me remind you of this again. You have a 60 and a 30, right? Larger angle, smaller angle. The tangents of these, there are only two options for the tangents of 30 or 60. It's either a root 3 or a 1 over root 3. So between the root 3 and the 1 over root 3, which is the bigger one? Root 3 is the bigger one, so it goes with the larger angle. 1 over root 3 is the smaller one, so it goes with the smaller angle. Okay? Because remember, it's the ratio of this side to this side. So that has a smaller ratio. This has a bigger ratio. Okay? I say this once in chapter 4, but I feel like it doesn't have the same weight. And then when I say it again, you're like, oh yeah, that's what you've been saying. Okay? All right, let's do one more and then we can continue later. Okay. Oh, look here. Look at what I have. Cosine, cosine, sine, sine. Right? That's the second half of the song. Cosine, cosine, sine, sine. Right? So that is cosine. So this is alpha and beta, alpha and beta. But look, there's a plus here. So that's the same as what if there is a plus there? Cosine alpha minus b. So 7 pi over 8 minus 5 pi over 24. I'm sorry, minus 5 pi over, 24. So this is cosine of, well, the 7 over 8, that's 21 over 24, minus 5, 16 pi over 24. But I can simplify that to 2 pi over 3, and that is negative a half. Okay? All righty.